Okay, hi everyone, I'm Elizabeth, and I've been really fortunate to make two projects out of my STEM scholarship. One of them is on face perception, and the other one is on depression. So I'm titling my presentation, Faces and Feelings. The first project is revisiting the left visual field advantage in face perception. So when we're interacting with people, we tend to think that no matter where their face appears in our visual field, we process that face exactly the same. However, in the last few decades, face perception researchers have actually found that we process faces faster when they're, we process faces better when they're presented in the left visual field than the right visual field. And when I say better, I mean more accurately and rapidly. So if I see a face in the left visual field, I'm more likely to recognize it. This is George Clooney, by the way. And I can tell his gender faster, etc. And then we abbreviate this as the LVF advantage. I looked a little bit more into the literature on this and actually became a little bit suspicious. If you look at this diagram, like each tiny hash mark represents the result of a study or a p-value. And then like in general, basically if a p-value is less than 0.05, so basically the p-values at like either ends of the figure, that's considered statistically significant. So like the experiment worked or there was a difference between the visual fields. You can see in the figure that there are a lot of p-values on the very left side, so which indicate that like lots of studies have found a significant left visual field advantage, which is as expected. However, there are also a few things that are a little bit unusual. First, there's also a cluster of p-values on the right side. And so some studies have found like significant right visual field advantages. And then by the way, the middle region is like not significant. When we go from both ends into the middle, the number of results like abruptly dropped off at p equals 0.05. If this was a natural distribution of p-values, we would expect the number of results to like gradually taper off. So this suggests that people are publishing findings when they're successfully finding significant results and not publishing them when they don't. This is called the publication bias. With this suspicion, my project just really had to start from scratch and investigate, does the left visual field advantage in face perception exist? As a first step to address this issue, I've pre-registered 6 tasks assessing this. And pre-registration basically just means like we submit our methods to journals before running the study. And then if the journal thinks that the methods are good, they would pledge to publish the results, no matter if we get significant or not results. And we ran about 70 participants for each task, which is greater than 92% of the studies in the previous literature. But we actually have 6 times that, so 420. I'll show you what a task looks like on the next slide. There's going to be a plus sign, and then once you see the plus sign, keep looking at it, don't look away. And then a face will flash on the left or right side. And then your job is to guess who the face is. It's gonna be pretty fast. It is okay if you don't get it. Okay, that was Ellen. The 5 other tasks are all pretty similar to this. And for each task, we measured accuracy and reaction time when faces were in the left visual field and right visual field for accuracy, and then when faces were presented in the left visual field and right visual field for reaction time. So it's gonna be a lot of lines on the next diagram, but basically each color represents a task. So 6 colors, 6 tasks. And basically like the different colored lines are all like pretty much flat. So for each task between the visual fields, performance is pretty similar. Not only that, you can see the 2 longer black lines. They are the overall like grand accuracy and reaction time. And they're both also pretty flat. So we also don't find any overall differences confirmed by statistical testing. So despite the fact that face perception research has been pretty confident in this left visual field advantage for many years, we're not seeing evidence for it. And our results are consistent with our view that there has been a strong publication bias. And it makes us wonder what like other visual field asymmetries have also been impacted. We actually believe that the field can make rapid progress on this question, but it has to be done by pre-registered studies across multiple labs. So that's my first project. And then my next project is an internship at Tsinghua University in China, funded by stamps. and it's about using GPT to help diagnose depression. So a student drew this, and the directions were to draw like house, tree, and person. It doesn't matter if it's like plural or singular, just draw whatever, house, tree, person. You can see that like not only did the student draw these three things, they also added like smiley faces and other elements. Sheep, yes, maybe sheep. So this test is called the house tree person test, and it has been used in the past as part of the process to diagnose depression. So we collected HTV drawings from students in China who also took a depression questionnaire. And then we did this thing called fine-tuning GPT to generate descriptions of drawings, which basically means ask GPT the right questions to make it describe the drawings. So now we have two groups of drawings by children who are classified as depressed from that questionnaire they took, and people who are not depressed. And then we performed sentiment analysis on the descriptions for these two groups. And sentiment analysis basically means like which group of descriptions sounds more happier or like more positive, have more positive emotions. And that sentiment analysis revealed no systematic differences between the two groups. However, we also did this thing called a support vector machine, which is basically this algorithm that sorts items into categories by finding like the best line between them. And then we use that to look for specific clues in the drawings for depression. And like our big result is that the support vector machine could do so 71% of the time. So the big question is like, can we use ChatGPT to diagnose depression? As of April 2024, which is when I did the project, the answer is like about 70% of the time, and you can take that percentage as you will. So those are the two projects that STAMPS made possible. And not only that, I've also had the Visual Field Advantage project accepted as a poster to an academic conference, Vision Sciences Society, and I'm going to that next week. In addition, STAMPS sent out this survey, and in the survey, it had a question: to what extent do you believe the STEM scholarship has influenced your postgraduate prospects? And for me, it's definitely significantly, because I've discovered that I love research. I like it so much that I'm now going to do a psychology PhD. And the picture on the right is my lab mates, my future lab mates, being excited after I told them that I was going to commit to Yale. Final thoughts to like any 27s or like younger classmen who like might be STEM scholars or just in general. I'm just really excited that you guys are all here to listen to all these presentations. And I think like this scholarship is a big deal, and it like can open doors for you, as Alex said. And then like in general, if you're like seeking an opportunity, just ask, and then the worst possible thing that they can say is no. Lastly, thank you to everyone for being here. Thank you to Professor Harner. Thank you to my entire STAMPS cohort. And then thank you to Brad Duche, my advisor, and everyone in my advisor's lab on the top right. Of course, this wouldn't be possible without support from STEM scholars. And I also have to thank the PI Liu Jia from my lab in Tsinghua, the Tsinghua Laboratory of Brain and Intelligence, for helping me on the depression project. Thank you, everyone. Mm-hmm. That's a great question. So this diagram on the very right, in vision, there's this thing called contralateral control, where your right hemisphere, or I guess your right hemisphere controls your left hand, and then your left hemisphere controls your right hand. And so is it for your right hemisphere controlling your left visual field. And then there have been a lot of studies measuring like brain activity that shows that the right hemisphere is more dominant in face perception. So this is why people had thought that like this also implicated at the visual field level. However, our results don't show that there's necessarily an implication downstream at the behavioral visual field level.
That's kind of both people are left-handed or right-handed, and then second, the cross-eye dominance. Some people switch.
For left-handed, yeah, so this like whole right controls left, left controls thing, some of it remains the same, but some of it exhibits a different pattern in left-handed people. And then I haven't like looked too much into cross-eyed dominance. Got it. Okay. So left visual field would be the left part of like both of your eyes. and then the right visual field would be the right part of both of your eyes. So like if you close one eye, you would still have like the left side be the left visual field and the right side be the right visual field. Yeah, so that would apply here.
We were studying this too far. I was wondering if you have subjective on the background to drawing.
That's a great question. So this is a supplemental, like GPT, one description that GPT gave for this drawing. And then you can see that like GPT like infer that this is nighttime, and then it correctly identified like house, person, tree, leaves, child, things like that. And like in the, like without GPT, when people have been doing this, they have this like big handbook of 85 features that a drawing may or may not exhibit. For example, like does the person actually draw like a tree, follow directions? Or are things like very spread apart on the image, or do they only occupy one space in the image? So those features were what we inputted into the support vector machine. Thank you.